Hey there, science fans! Ready to dive into the wonders of the physical world? Have you ever thought about how things work? From gears in a clock to forces keeping planets in orbit? Physics is the key to unlocking the mysteries of our universe. It studies the fundamental laws from atoms to galaxies. Imagine understanding the forces shaping the cosmos. Physics is like a giant puzzle. Each discovery helps us see the bigger picture. It's a journey of discovery, helping us understand the world and beyond. From smartphones to stars, physics is everywhere. It's the foundation of modern technology. Understanding physics is crucial for innovation and progress. Engineers and scientists use physics to improve designs and create new technologies. So buckle up for an exciting adventure into the amazing world of physics. Welcome to 10-Minute NEET Preparation, where we make learning physics fun and easy. If you enjoyed this video, like, share, and subscribe. Let us know in the comments what topics you'd like us to cover next. Let's start with the classics, shall we? Classical physics is like the wise old sage of physics. It deals with the laws of motion, gravity, electricity, magnetism, and thermodynamics. These laws were mostly discovered before the 20th century and are still used today to explain a wide range of phenomena. Think of Isaac Newton and his apple. That's classical physics. How about lightning or the sound of a guitar? Also classical physics. It's the physics of everyday experiences. Classical physics laid the foundation for our understanding of the physical world. It's like the sturdy base upon which we've built our modern technological marvels. But as scientists dug deeper into the nature of reality, they stumbled upon some strange and unexpected phenomena that classical physics couldn't quite explain. That's where modern physics comes in. In the early 20th century, physicists began to explore the realm of the very small, the world of atoms and subatomic particles. They discovered that the laws of classical physics didn't quite apply in this bizarre and wonderful domain. Modern physics is like the daring explorer venturing into uncharted territories. It deals with mind-boggling concepts like quantum mechanics and Einstein's theory of relativity. It's the physics of the very small, the very large, and the very fast. Imagine a world where particles can be in multiple places at once or where time is relative. That's the mind-blowing realm of modern physics. It's a world where our everyday intuition is challenged, and we're forced to expand our understanding of reality. Now, how do physicists describe the universe? Well, they use measurements. Measurements help us quantify the physical world and communicate our observations in a clear and consistent way. Whether it's the distance to a star or the mass of an electron, physicists rely on a system of units to make sense of it all. The International System of Units, SI, is the standard system of measurement used by scientists worldwide. It includes base units for fundamental quantities like length, meter, mass, kilogram, time, second, and electric current, ampere. From these base units, we can derive units for other quantities such as speed, meters per second, or force, newtons. Think of it like baking a cake. You need to use the right measurements to get a delicious cake, and in physics, you need the right units to get accurate results. Just as a baker uses cups, teaspoons, and grams to ensure the perfect recipe, physicists use meters, kilograms, and seconds to ensure their calculations are precise. Over time, the tools and methods for measurement have evolved, becoming more accurate and reliable. This evolution has allowed scientists to make groundbreaking discoveries and advancements in technology. From the ancient Egyptians using cubits to build the pyramids to modern-day scientists using atomic clocks to measure time with incredible precision, the journey of measurement is a testament to human ingenuity and the quest for knowledge. So, the next time you measure something, whether it's for a science experiment or just baking a cake, remember the importance of units and standards. They are the foundation of our understanding of the universe and the key to unlocking its many mysteries. Section 5. The Fantastic Four, Fundamental Forces of Nature. These forces are the pillars upon which the entire universe stands. Hold on tight because physics gets even more exciting. We're about to dive into the very fabric of reality. The universe is governed by four fundamental forces. These forces are the unseen architects of everything we experience. These forces are like the invisible glue that holds everything together. First up, we have gravity, the force that attracts any two objects with mass. It's why apples fall and why we stay on the ground. Gravity keeps you grounded and makes planets orbit the sun. Next, the electromagnetic force governs interactions between charged particles. It's behind electricity and light. Imagine a world without light or electricity. Impossible, right? Then there's the strong nuclear force holding the atomic nucleus together. It's the strongest force but has the shortest range. Finally, the weak nuclear force is responsible for radioactive decay. It plays a crucial role in nuclear reactions that power the sun. Understanding these forces is key to unraveling the mysteries of the universe. They are the threads that weave the cosmic tapestry. Section 6. Like a detective unraveling mysteries with the scientific method. Now, how do physicists actually study the physical world? They use a systematic approach called the scientific method. It's like a roadmap that guides scientists in their quest for knowledge. It's all about observing, questioning, experimenting, and drawing conclusions based on evidence. First, you make an observation about the world. Then you ask a question about what you observed. Next, you form a hypothesis, which is a testable explanation for your observation. Then you design an experiment to test your hypothesis. You perform the experiment and analyze the results. Finally, you draw a conclusion based on your findings. The scientific method is a powerful tool that allows us to test our ideas, refine our understanding, and build upon the work of others. Section 7. Physics in action, from your coffee maker to space travel. Physics isn't just some abstract concept confined to textbooks and laboratories. It's all around us, shaping our everyday lives in countless ways. Think about it. Your smartphone wouldn't exist without our understanding of electromagnetism and quantum mechanics. Medical imaging techniques like X-rays and MRI scans rely on our knowledge of physics. And let's not forget about space exploration, which wouldn't be possible without our understanding of gravity and rocket propulsion. From the simplest of machines to the most complex technologies, physics is the driving force behind it all. Section 8. The power of physics, shaping our understanding. Physics isn't just about understanding the physical world, it's also about understanding our place in it. It challenges our assumptions, expands our horizons, and inspires us to dream big. By studying physics, we gain a deeper appreciation for the beauty and complexity of the universe. We learn about the fundamental laws that govern everything around us, from the smallest subatomic particles to the largest galaxies. Physics helps us make sense of the cosmos and our place within it. It's a journey of discovery that leads to a deeper understanding of ourselves and the world around us. Section 9. Classical and modern physics working together. Now, you might be thinking that classical and modern physics are two completely separate realms. But in reality, they complement each other beautifully. Classical physics provides the foundation for understanding the macroscopic world, while modern physics helps us delve into the microscopic realm. For example, our understanding of electricity and magnetism, rooted in classical physics, paved the way for the development of electronics and telecommunications. And our knowledge of quantum mechanics, a cornerstone of modern physics, is now being used to develop new technologies like quantum computers. Classical and modern physics work together to paint a complete picture of the physical world. They're like two sides of the same coin, each essential for a comprehensive understanding of the universe. Section 10. Physics, a never-ending quest. The study of physics is a never-ending quest for knowledge. Every answer leads to new questions, and every discovery opens up new avenues of exploration. Physicists are constantly pushing the boundaries of what we know, seeking to unravel the deepest mysteries of the universe. From the search for dark matter and dark energy to the quest for a unified theory of everything, physics is teeming with unanswered questions and unsolved mysteries, and that's what makes it so exciting. There's always something new to discover, always something new to learn. Section 11. Go forth and explore. So there you have it, an introduction to the amazing world of physics. We've explored the realms of classical and modern physics, delved into the world of measurements and units, uncovered the four fundamental forces of nature, and touched upon the power of the scientific method. We've seen how physics shapes our everyday lives, and how it continues to inspire us to reach for the stars. Now it's your turn to go forth and explore. Keep asking questions, keep experimenting, and never stop being curious about the world around you. The world of physics is vast and full of wonder, just waiting for you to uncover its secrets.